Okay, first off, reminder that your plant projects are due on Monday. Okay, you've had quite a while to work on those, so make sure that you're getting those completed. Okay, second thing, yesterday I put in your report card comments, okay, for this first kind of half of the course. Okay, and I think maybe some people maybe took some of my comments that I put in maybe the wrong way or maybe a little bit personally. And of course, it never meant for that. So I think I need to explain maybe a little bit better what we were talking about yesterday in terms of, AP versus regular academics and things like that. Okay. As I said yesterday, you can choose to take AP regardless of what your mark is in this class. You have that right. Okay. So if we say to you, we have a recommendation, that isn't meant as an attack or for anyone to take it personally. It's just that. It's a recommendation from people who have been doing this for, well, in some cases, a very long time. Okay? So the general rule that I follow, okay, is that if I think a student's grade says that they are sufficiently challenged by a regular academic stream, then I recommend that they stay in a regular academic stream. Okay? My typical cutoff for that is about 85. Okay? So I typically would put in as a comment that if you had like 85 or less, and for whatever reason, your mark can still go up before the end of the semester. So this is not a permanent thing, and I hope no one took it that way. But if your mark goes up and you're saying, oh, you know what, I maybe just had a rough start, and that happens, especially semester 1 in grade 10, then, when your mark goes up and it's in the 90s, and you're like, okay, I got this figured out, I can totally handle the extra material, the extra difficulty, and the extra challenge of AP, then good on you, go for it. Okay? There's nothing saying that my recommendation is set in stone or that you have to follow it. Okay? It's just my recommendation from what I've seen thus far. Okay? I know what the AP level requires. Okay? And I know what's in the regular stream as well. Okay? And I know that especially in grade 10, it's easy to kind of be shell-shocked early by the amount of work and how different that is from junior high. Okay? So if I put in a comment that said, I recommend that, that the regular stream will be challenging enough, I didn't mean to hurt your feelings. And I didn't mean that for you to take that as Coderre doesn't think I'm smart enough, because Coderre thinks you're all smart. Okay, I'm just putting that out there. Okay, but know that sometimes I can see that this is enough. Okay, and really, in the end, right now there are 120 some Science 10 AP students. Okay, this semester. There are that many. Typically, Chem 35 AP, which is the last science AP course you can take, rarely has more than 20 kids in the class. Okay, and that's not because we're washing people out. Okay, it's not because we're saying so-and-so didn't make the cut, I'm cutting you. Okay, there was tryouts and you got cut. That's not at all what it's about. It's about people realize, oh, you know what, I really don't want this much extra work or need this much extra challenge, or I'm feeling overwhelmed with what's already here and I'm good enough to stay here. And you know what, guys, honestly, when they look at your transcripts for university, they don't care whether you took AP or regular stream. Okay, they really don't. It doesn't make a big difference. Okay, so I hope no one took it personally. Okay, that's just me honestly looking out for you. Okay, and saying, I want you to have a good high school experience where you don't feel, overwhelmed, anxious because you're getting behind or you're worried about your mark or whatever. I don't want that experience for anyone. That's where my recommendations come from. Okay, I think people took them as they came from maybe a place of cruelty when they come from a place of kindness. Okay, and I know maybe it's hard sometimes to take it that way. Maybe it's the first time you ever got a report card comment that wasn't all smiles and sunshine. Okay, and it wasn't meant to be hurtful or to hurt anyone's feelings or self-esteem or anything like that. Okay, just take it for what it was worth. It's what Coderre has seen thus far. okay? And obviously, we're only halfway through. We have 2 more units, okay? You guys are kind of getting the hang of grade 10. Things can change, and you know what? I'll happily eat my hat, okay? If things, you know, really change for you in the second half of the course, goes a whole lot better. That's great. That's what I want, okay? So just I hope no one was hurt by it or took it personally, okay? The second thing, because I had a couple of emails about it, participation in class. I have mentioned over the last little while that it would be nice to have more participation from you guys during the quiz. People are answering questions. That's great. That's what we're looking for. Being actively engaged in class is important because if you're not, it's easy to miss material. And I've just been noticing that there's been a bit of disengagement, so I did put in a lot of comments, okay, about, you know, it'd be great if, you know, there was more active engagement. Again, it wasn't meant as an attack on anyone personally, just pointing out that there's value in it, okay? Not saying, you never say anything, I don't know what your voice sounds like. Wasn't saying that at all. It was just pointing out the value of being an active participant in class. And quite frankly, guys, that's hard for you, and I get it, and here's why. You have had much of your important developmental years interrupted by COVID. You had to learn online for 2 years, and that is very different than learning in a real classroom, okay? It's, let's say, easy to hide in an online classroom, okay? It's easy to, you know, turn off your camera and turn off your microphone and hide, okay? And I know that that happened, and nobody's mad about that. It was the nature of the beast, okay? It's what we had to do. So we understand that you guys are not used to, as comfortable with, or even familiar with how to be an active learner. It's something we talk about all the time in our professional development. What can we do to help kids be more active learners, okay? And one of the big things is point out to them when they're not, okay? And show them, tell them, like, look, if you guys answer questions, if you interact a little more with me when I'm up here, that's gonna help you be an active learner. Active learners are more than passive learners. It's just like diffusion and active transport, okay? You get more out of it, okay? Does that sort of make sense to everybody? Okay, so again, I hope it didn't hurt anyone's feelings. That wasn't my intent to do that, okay? And if I did, I'm sorry. Okay, scalars and vectors. We kind of ended the day talking about scalars and vectors a little bit yesterday, just to kind of introduce the idea. Today I'm going to kind of formally go over scalar quantities and vector quantities because they're super important for physics. Okay, so there are many ways of measuring how far apart or how fast objects are going. Okay, I can measure that from a scalar perspective with speed, or I can measure it from a vector perspective with velocity. Okay, I'll give you an example. Actually, I'll ask you this question. Speed and velocity, up until now, have you considered those to be the same thing? Probably, right? I mean, that's the way that 90% of people think, is that these two things are the same, okay? But I ask you, have you ever heard of anyone getting a velocity ticket? Speeding ticket? Yeah. But not a velocity ticket, because there's no such thing, okay? Velocity is actually a vector quantity, okay? And it measures how quickly you're changing your position. And that means it also has a direction, okay? So here's the difference. If, and this of course wouldn't happen to anybody in here, let's say you got pulled over, okay, by the police on the Deerfoot because you were going 130. Okay, nobody would do that, obviously. Okay, but it's just hypothetical. So the police officer comes up, and they do their usual traffic stop thing. How are you doing today? Do you know how fast you were going? If you tell them your velocity at that point, if you say I was going 130 kilometers per hour at 17 degrees south of west, there will be a follow-up question. And how much have you had to drink today? Because that's a weird way to answer that question, okay? You're going to be performing a field sobriety test, okay, for answering the question with velocity. What do they want to know? Your speed, that's why they asked how fast. If they wanted to know your velocity, they would have asked how fast and in what direction are you going? And then the 17 degrees south of west would have been an appropriate answer. Okay? But in this case, it's really weird, and it's going to make them suspicious. Okay? So you just say, 130 kilometers per hour, officer. I'm really sorry. Okay? And you should be, because that's way too fast. Okay? All right. We need to differentiate between distance, displacement, speed, and velocity. So that's the difference between speed and velocity. It's the same thing between distance and displacement. We looked at that yesterday. Distance is how far you actually have to travel to get from point A to point B. Because most of the time, you can't go in a straight line. Your displacement is the straight line and its direction. So how far and in what direction you're going. So displacement and velocity are vector. Speed and distance are scalar. They don't care which direction you're going. Okay, is that making sense to everybody? Now, the third thing that's involved is time. Is time a vector quantity or a scalar quantity? It's scalar, but we treat it and we speak of it like it's vector because we say stuff like this. Oh yeah, that's 10 minutes west of here. Well, that would imply that time is west. Time is not west. I'm going to travel in a westerly direction for 10 minutes, but time, that 10 minutes is forward. That's the only way time goes, by the way. Okay, at least with our understanding of linear time, that's the only way time goes. Unless you have a time machine, okay, then you know something I don't. But as far as we know, time is scalar because we can't make it go different directions. It simply passes, and that's it. Okay, does that make sense, everybody? Okay, so time is a scalar quantity. It does not have a direction, and we should never assign a direction to it like we often do, okay, in our normal use of language. Okay, 10 minutes north, an hour and a half south. Like we talk about it like it's vector, but it really isn't. All right, and then we're going to solve problems related to motion, okay, and that is going to involve us using these two formulas. V equals d over t, and V equals d over t. No, I'm not crazy. You might think so, but that's okay. Those are two different formulas. Okay, and here's why. The little arrow that's over top of V and D in the second formula denotes that they are vector quantities. Okay? If it doesn't have an arrow over top of it, it's a scalar quantity. So this formula is saying that speed equals distance divided by time. If I wanted to calculate the speed, the average speed over an entire trip, I would add all the little separate distances together. I would add all the separate times together, and I would divide it. Distance divided by time. I have my total distance divided by my total time, and that would give me my speed in either meters per second, kilometers per hour, whatever my units of measurement were. Okay. This one is velocity equals displacement divided by time. If you had to manipulate either one of those formulas, you'd manipulate them in exactly the same way. Okay? You just have to recognize that velocity and speed are different things, and distance and displacement are different things. Okay, questions so far? Okay, those formulas, actually that formula, is on your formula sheet. Okay, it's not written in two different ways, but it's on there. Okay, so if you've ever gone hiking off trail or done any orienteering, you well know that how we describe everyday travel or life, travel in everyday life is really bad. It's what we talked about yesterday when I asked you, how far is it to Edmonton? And most people were thinking, oh, like 3 hours, okay? How far isn't how long, okay? So it's a problem that we have, okay? And it's easy to fall into that trap because that's how we've been trained to think, okay? And it works fine for most situations, but it can bite you, okay? I had it bite me a number of years ago, okay? I was out actually backpacking in the summertime with another physics teacher, friend of mine, and we were backpacking and we had this day where we went like 36 kilometers, 2 mountain passes, and it was the end of the day. We were out of water. There wasn't a creek around to filter anything from, so we were dehydrated, we were hungry, we were tired, and we thought we might be lost because we hadn't gotten to the campground we were supposed to be at, and we figured we should have been there already. We didn't think we were as slow as we were. So we sat down and we're like, okay, let's look at the map, let's think logically about this, which is hard to do when you're dehydrated, hangry, okay, tired. And we're looking at the map, and all of a sudden this guy in army fatigues, carrying a pack that was easily twice as heavy as ours, comes running up the hill towards us. And we're like, oh sweet, this guy will know because he's coming up the trail, he'll be able to tell us. So we wave him down and we're like, dude, like, do you know where Tumbling Creek Campground is? Like, we think we should be there, but we're not there yet. And he looks at us and with this like really proper English accent that I can't even try to imitate, tells us, oh yeah, it's 20 minutes down the trail. And we're like, sweet, thanks. And off he goes, jogging with his 80-pound pack on, okay, uphill. So an hour later of walking downhill with lighter packs, mind you, we stumble into Tumbling Creek Campground. They should call it Stumbling Creek Campground after this, but that's, okay. We get there and we're like cursing this guy. We are planning how we are going to hunt him down for telling us it was only 20 minutes, okay? Then we have some water, we have some food, we start thinking a little bit more clearly, and I look at my buddy, I'm like, Sean, do you know what we just did? And he looks at me and goes, yeah. We let somebody tell us how long it took them to do something as a measure of distance, because we're science nerds and that's how we would talk at that point, okay? And I'm like, that is so embarrassing. Can you imagine? Like, this is probably some like special forces guy who's out for a training job with his heavy pack. We're two out-of-shape teachers on their summer vacation. Of course he was faster than we were, okay? But we allowed him to tell us the campground was 20 minutes away as a measure of distance. Now, had we not just been so tired and dogged that we just kept following the trail and eventually got there, that could have ended really badly. We could have gone, we must be lost, turned around and gone the wrong way and actually gotten lost, okay? It's a situation that can be dangerous if we're not careful about it. In everyday life, it's not going to endanger you. It's going to be inconvenient. It might tick you off if you don't get somewhere when you think you should, okay? But it's something that's not correct, okay? But it's easy to fall into that trap. Okay, so if I'm looking at like, if I'm on a road or I'm on a path and there's a sign and it says, so let's say I'm here at Seldom Inn Campground and I want to go here to Snake Indian Falls Campground. I see a sign right here and it says Snake Indian Falls Campground, 28 kilometers. What is it telling me? It's telling me the distance. Why is that the best thing for it to tell me? People will walk there at different speeds, and what does it assume I'm going to do? Walk on the trail. Okay? It assumes I'm going to be smart, which is maybe a dangerous assumption, okay? And I'm going to follow the trail. Along that trail, it's 28 kilometers. It doesn't say Snake Indian Falls Campground, 19.8 kilometers at 49 degrees west of north. Okay, which would be correct, but I would have to follow this path because this would represent the displacement or the vector measure of my change in position from point A to point B. Unless I have a helicopter, that is not a useful measure of how far it is to that place from here because I can't go this way. This gray stuff, that's glaciers. Okay? All these little gray squiggly lines are rivers. If you're not on a trail, there's no bridge. Okay? There's all manner of disaster along that line for a person on foot. Okay? So there's a time and a place for both types of measurement. If I'm on foot, the scalar measurement is far more appropriate. If I'm in a search and rescue helicopter, which one do I want?
The vector.
I want the vector one. I don't have to worry about following a path. I just need to get there quickly. So I want the displacement. I want the change in position. And this is something you would have to do if you were like a pilot, if you were like a cruise ship navigator, okay, or something like that. This vector stuff is all what you have to do, right? Because in those places, you can actually go in a fairly straight line from one point to another because you don't have to worry about following a road. Okay, so one is not better than the other. People get this idea that because vector quantities have magnitude and direction, that they're somehow better or more accurate. They're not. Okay, there's a time and a place for each one. Okay, so if we say Calgary is 40 kilometers away, we don't make a reference to which direction Calgary is. We just get on the road and follow the signs. Okay, and we get there, and we travel a distance of 40 kilometers. Okay, that's a scalar description. If I say that Calgary is 40 kilometers at 13 degrees east of north, that would be the vector description, that would be a straight line. Okay, which I couldn't follow unless I had a helicopter. Okay, am I following the difference there? Okay, so I was saying a minute ago, one is not more accurate than the other. Okay, but people get this idea that vector quantities are more accurate. A vector quantity can be less accurate than a scalar quantity, and vice versa. Accuracy isn't determined by whether I give direction or not. Accuracy is determined by how I measure something. Okay, so it's the way in which I measure things. So let's say that I measure this distance from Okotoks to Calgary, and I measure it with an old car, and the odometer, you know, the thing that tells you how far you've driven, doesn't have any decimals. So it only shows kilometers as the last digit. Okay? When I get from Okotoks to Calgary, I know I have gone, well, or the odometer will say 40 kilometers. That means that my trip was somewhere between 39 and 41 kilometers, because that particular device only measures to plus or minus 1 kilometer. If I'm in a more modern car that's got the small thing that measures every 1/10 of a kilometer, when I get there, it will read 40.1 kilometers. Okay? That is more accurate because it's measured to the nearest plus or minus 100 meters. Okay? You want to follow the difference there? Okay? So accuracy is determined by how you measure, not by whether or not you give direction. Okay? Okay, let's do this. Let's talk about this example. And I get you guys to copy this one down. Okay, so let's say I want to go from HTA, which is over here, and I want to go to Walmart for some reason. Okay? Well, by comparison, Walmart would be like here. This is not drawn to scale. because otherwise these things would be huge. Okay, so I would, go out the parking lot, okay, and you get to 32nd Street, you gotta go down 32nd Street, and then I'd probably go right to the highway if it were me, okay? And so I'd go on the highway, get to the highway, turn on the highway, okay, go past Walmart, okay, turn onto Southridge Drive, come back, the Sobeys is like right here, okay, come back through that little road and get to Walmart. Okay? Everybody all right with that? So let's say that after I've done all that, I have no idea how far that is, but let's just say it's 10 kilometers. Okay, is that my distance or my displacement? That's my distance. There's no direction on that because I went many different directions over the course of traveling that distance, right? I came north out of the parking lot, I went west, then I went south, then I went west, then I went north, and then I went east, and then I went south. I went a whole bunch of different directions on the course of that trip, okay? So that's my total distance traveled. Is that how far Walmart is from here? Not in a straight line. It's how far I have to travel to get there, okay? But Walmart, in a straight line, is that far? I'm going to say it's probably more like 6.2 kilometers, and I'll say probably about 43 degrees south of west. Okay? So let's say that that trip took me 10 minutes. Okay, that's 600 seconds. Everyone all right with that conversion? Okay. All right. So let's say that that trip took me 600 seconds. Right. Can I calculate my speed? I can. Okay. Speed, if we recall earlier, I'm going to use purple for. Okay. Purple for. Speed is distance divided by time. Okay. 10 kilometers is 10,000 meters. Okay. And that took 600 seconds. All right, so that means I'm going 16.7 meters per second. That might be a little faster in town. That's what happens when I make up numbers. So it's a little fast, 60 kilometers. Okay, so I'm going 16 meters per second along that trip. Can I calculate my velocity at this point as well? Okay. Is it the same or different than my speed? It's different. Okay, because velocity is vector, and it's displacement divided by time. I only changed my position by doing this trip by 6.2 kilometers at 43 degrees south of west. Okay, that's how far I actually am in a straight line from HTA by being at Walmart. And again, I made these numbers up, so I could be totally wrong on these, but, okay. We'll say 6,200 meters divided by 600 seconds. Okay, and I also need to include on here that that is at 43 degrees south of west. It's a vector quantity. Okay, so if I take the 6,200 meters, obviously I can't put direction into my calculator, divided by 600, okay, I get 10.3. So my velocity then is 10.3 meters per second. Which way? Okay. 43 degrees south of west. Right? I'm talking about the same trip. There's no way that my rate of changing my position can have a different direction than the change in position itself. Okay? It would be like saying, I went 200 kilometers south by traveling at 85 kilometers west. Or 85 kilometers per hour west, sorry. Okay? Is that possible? For me to travel at 85 kilometers per hour west and end up 200 kilometers south? Not possible at all. Okay? My velocity and my overall displacement always share a vector because they're talking about the same trip. They have to share a vector. Okay? Because they're going the same way. Right? So my velocity would have the same vector as my displacement. Okay, so let's say that this is me doing this trip. I'm getting old, so my mind's not as sharp as it once was. I get to Walmart and realize I don't have my wallet or my phone, so I can't buy anything. Well, I'm not going to walk around Walmart for the fun of it. Okay? So I just get right back in my car and I drive exactly the same route back to the school. Okay? What's my total distance traveled now?
20 kilometers.
20 kilometers. Okay? And let's say it took me exactly the same amount of time to get back. So now my total distance, as we said, is 20 kilometers. And my total time is now 1,200 seconds. Okay? Is my speed still the same? My average speed over the whole trip still the same number? Yeah, it is, and we can verify. Okay, we can go 20,000 meters divided by 120 seconds. Okay, it's supposed to be 12. Not 100. It's supposed to be 1,200. 20,000. But 1,200. Missed the zero there. Okay. Still the same speed? Yeah. Still 16.7 meters per second. That's my overall speed. Okay. Now that I'm back at the school, what's my total displacement? Zero. Okay. Remember that displacement measures your change in position. And because my starting position was HTA and my final position was also HTA, I have technically not changed my position. I may have traveled 20 kilometers, but I came back to where I started from. Therefore, my displacement, change in position, is now zero. So, what's my average velocity over the whole trip? Okay, I'm going to give you the definition of velocity again, so you can tell me what the answer is. Velocity is the rate of change of position. What was my change in position? Zero. What's my rate of change of position? Zero. I haven't changed my position. There's nothing to have a rate for. Okay? Mathematically speaking, it would look like this. Oh, sorry, it's supposed to be in blue. Okay, so my velocity would be my total displacement divided by my total time. Well, my total displacement is zero. It doesn't matter how much time it takes. Zero divided by anything is 0. Okay? I have no velocity in this case. This is exactly why the odometer on your car doesn't measure displacement. It measures distance. It will tell someone when they look at your car how far you have driven it, how many kilometers are on your car. If it measured displacement, what would it read every time you come home? No, it'll read how far it is from the dealership you bought it at to your house. It'll read 0 when you take it in for an oil change. I have yet to have someone get that answer. Okay, but yeah, it'll come back to a very small number. We'll say it's 0 just because I'm being mean to you. Okay, but it's going to read 0. Well, that's great for you if you go to sell the car. You could have driven it around the world 20 times, but it'll say 0 because the odometer reads displacement. That's useless, unless you're trying to sell the car. Okay? Back in the day, when there were actually like mechanical odometers, not computerized ones, people would pull the clear plastic off the dash and spin them back mechanically, okay, so that the car looked like it only had 100,000 kilometers on it instead of 500. Okay, it was very dishonest, but people did it. You can't do that now with a computer in the car because the computer would have to be hacked, which I'm sure there's somebody who knows how to do that, but it is very dishonest. But they read distance. They read how far the car has been driven, which is a much more accurate measure of how worn out the car might be. Okay. So again, there's an example of when is it appropriate to use a scalar quantity, when is it appropriate to use a vector quantity. In that case, scalar is definitely more appropriate, right? And same with your speedometer. It reads how fast you're going. Can you imagine how complex that instrument would be if it read velocity? It would have to be a speedometer combined with an old-fashioned like ball compass. And it would constantly be rotating around while showing you how fast you're going and in what direction. It would be like so distracting that it would cause car accidents all the time. Okay, it's far more appropriate to go, I'm on the road, I just need to know how fast I'm going down this road. It doesn't matter what direction I'm going. I mean, sure, you have a compass up on your mirror maybe, okay, but it's not measuring your velocity. It's just telling you which way to go. Okay, questions on how that works? Okay, do we see the difference now between a trip looked at from a scalar perspective and a trip looked at from a vector perspective? Okay, they're talking about the exact same trip, but they are looking at it from very different points of view, and so they get very different numbers. All right, let's take a little break here. Okay, let's pick up here. I briefly went over this yesterday. This is the algebra of using v equals d over t. Okay, so if I need to manipulate, okay, to solve for something else, I will obviously not be using a triangle for that because triangles are no good. Okay, so I'm not going to use them. But if I want to manipulate this equation, okay, then I've got to follow those 3 rules of algebra that we wrote down again yesterday. If I want to move something, I perform the opposite operation. Okay, what I do to one side of the equation, I have to do to the other side of the equation, and I move what's not attached first, which doesn't apply to this formula because everything's attached in this formula. Okay, so if I wanted to solve for d, how do I isolate d?
Times it by t.
Right, I got to multiply both sides of the equation by t. So, I'm going to move t over here, okay? T times v is going to equal d. Everybody all right with that? Okay. Now, what if I want to solve for t? Right, well, it would be over here, okay? T will equal d over v. Now, here's the thing I want to caution you about because people do this sometimes. Okay, they're like, oh, I don't like algebra, so I'm just going to write down every manipulation of every formula on my formula sheet. How long will that work for you? It'll work until the test. When I give you a new formula sheet that doesn't have all the manipulations written on it, okay? I don't want that for you. That would suck. Okay, so we got to make sure we're learning our algebra skills here, okay, learning how to manipulate equations, because there's going to be a lot of them, okay, that we're going to have to manipulate, right? It's pretty simple stuff. We just have to practice it, okay, in order to get good at it, just like anything else. Okay, so we got to be able to move things around without using a triangle, because obviously when we get to formulas, that a triangle is not going to work for. Okay. All right, so we copied those down yesterday, so we can skip over those. And I don't know why I have that on twice. All right, I want you to copy this one down, and then we're going to walk through it together. Okay, so the first problem is, how far will a deer running at 15 meters per second travel in 45 seconds? Okay, so just like a mole equation question, the first thing we want to do is write down what the question gives us and what we're looking for, right? So how far? What am I looking for if it says how far? Distance, not displacement. If it asks how far and in what direction, I'd be looking for displacement. Here it just says how far. All right, so I'm looking for D. Okay, will a deer running at 15 meters per second, what did they give me there? Speed, yeah, this is the speed. How do I know it's the speed? The units can usually tell me. Meters per second is a measure of the rate at which I change my distance. Okay, but also because kind of at the context of the question, how far will a deer running at 15 meters per second implies that this is how fast it's going. Okay, and then the last part is in 45 seconds. What do seconds measure? Okay, so then that's T. All right, and that's how I have to read through a question. Okay, and I know right now you're probably going, whatever. You're belittling my intelligence. Like obviously I know that, and I'm not trying to do that. These get a lot more complex. So you get into physics 20 and especially physics 30, and reading through a question and being able to decipher what that question is giving and what that question is asking for becomes like a reading comp exercise. Okay, I don't know if anyone's taking English right now, but okay, like we did a thing in CLCs one time with reading comp with the English teachers, and like we failed, especially as science people. Okay, like I think what did I get? 4 out of 7. Okay, because I was like, I don't know, I think that this passage means this or is saying this, and they're like, no, it's saying this. I'm like, I totally didn't get that. Okay, so we have to get good at reading through a question and going, all right, what is in this question that I can use? What is this question asking me to get? Okay, and the reason we're doing that, we have seen on the physics 30 and chem 30 and bio 30 diploma exams, situations where a student has to read a page of text and answer one question. Okay, in some cases in physics 30, it's been read a page of text and there's one question with one calculation. And I'm supposed to get everything I need for that calculation from reading a page. Okay, and it takes people a long time, not because they're slow readers, but because they have to read it a couple of times to get everything they need to do the question. Okay, so that's why we're saying it's really important to read a question, and some of the information is contextual. This is a deer, it's running, that's the context of the question. It's pretty simple, I'll grant you, okay, but they'll get the context will become more complex as you go along. All right, so I'm looking for D, okay? You would get a mark for your givens on a question like this, okay? Just like you did with the mole equation. Now, I'm looking for D, and I have V and T. My formula sheet's got, what, 15 formulas on it? Do I have a formula that has those 3 things in it? Yes, it's the formula we've been using already, this one. Okay, so usually I give you a mark for that because, well, there's formulas to choose from and you chose the right one. Okay, in this situation, I'm looking for D and the formula is not set up for that yet. So I have to manipulate it. So I would multiply both sides by V and then plug in my numbers, and that would be another mark. Okay, so we would have our 45 seconds. Sorry, I'm still getting used to this board. 45 seconds times 15 meters per second. Okay, then I punch that into my calculator. Okay, 675 meters. How did I know the units were meters? is distance usually measured in meters? Or kilometers, right? But here's the other way I did it. When I did this operation, I was going 45 seconds times 15 meters per second. When I multiply these numbers, there's a seconds on the top and a seconds on the bottom. What do? All right, they cancel out. That leaves me with meters. Okay, so there's a mathematical way to get the right units, and there's a contextual kind of common sense way to get the right units. It asks for distance, and distance is in meters or kilometers or whatever. I look at the question and go, well, it was meters per second, so my answer is probably meters. Okay. Either way will work, whichever way makes more sense to you. Okay, is that a pretty simple question? All right, try this one. Write it down, okay, and give it a try yourself, and we'll walk through it. Okay, so in this question, they're asking how long it will take. What does how long it will take mean I'm looking for? Time. Okay, how long will it take a tortoise to crawl 200 meters? Distance. Okay, at a speed of 0.25 meters per second. So they actually outright say here, this number is speed. And sometimes the question's that basic. Okay, meters per second. All right, so that would mean, again, I'm using this formula, V equals D divided by T, but I'm looking for T, so I can't solve for something if it's on the bottom of an equation. Okay, so I need to move it over to the other side so that it ends up on the top, and then I have to move V over here. Okay, so I'm going to have the T equals D over V, 200 meters divided by 0.25 meters per second. When you're doing this on paper, you don't necessarily have to put in the units. I'm just putting them in there for clarification. Okay, when I do this myself, I don't usually put the units in. Okay, so it's going to be 800. Okay, so it's going to take 800 what? Seconds. How did I know? How did I know it was seconds? Exactly. The meters cancel out, right? I got meters divided by meters per second. Meters go away, left the seconds. Okay? Everybody all right with that? Okay, so these are pretty straightforward. Now, these are pretty simple ones. They only have one part to them. Okay? We're going to get into questions where we go this way and then go that way, and it's got some vectors in it. Okay? You're never going to have to do any trigonometry. Okay? So even though I gave you a situation with compass directions in it, the only compass directions you're ever going to get are like north and south. We only do what we call one-dimensional vector analysis in Science 10. So that would be forward and backward, right and left, east and west. You're never going to have an angle and a triangle, and you're never going to have to do trig. First thing you do in Physics 20 is vector analysis in 2 dimensions with trig. Okay, just so you know, that would be like the first thing you would do, basically, in Physics 20. Okay, so this is an example of a vector question with 2 parts. And we got time. So just have you write this one down, and then we're going to walk through it. Actually, I'll even give you a minute to give it a try, see if you get it, and then we'll walk through it. Okay, so in this question, we have a bus travels 100 kilometers north in 1.2 hours. Then it turns and travels 62 kilometers south in 0.9 hours. So what does it do that none of our other questions have done? It turns around, it changes direction. And like we said, this is one-dimensional vector analysis. It went north and then it completely backtracked. Well, not completely, but it came back quite a ways. Okay? Everyone with me so far? Okay, so if I'm looking at this, can I right now know what the total distance traveled was? What's the total distance traveled here? 162 kilometers. It went 100 north, went 62 south, but distance is scalar. It doesn't care which direction you go, just how far. Went 162 kilometers. Okay? Now, This wants to know what's the average velocity. That's vector. Okay? So, if I want to do this, okay, what I want to do is break up my givens into the two parts of the trip. Okay, and then I'll have totals. So what a lot of people do when they're calculating average velocity is they find the velocity in the first part, they find the velocity in the second part, and then they do what they've been taught their whole lives, is the way to calculate an average. They take those two numbers, they add them together, and they divide by 2. Why will that not get you the right answer in this situation? Okay, if I calculate the average grade in this class, I do it by taking all your grades, adding them together, and dividing by 32. But that assumes that you are all what? It assumes you're all equal parts of the class, and you are. In this situation, one part of the trip is considerably longer than the other, and thus will affect the average velocity more than the other part. So I can't just figure out what the velocity in the first part is, take and add it to the and average it with the one from the second, because that assumes that they're equal parts of the trip, and they're not. Okay? What we're calculating here is a weighted average. Okay, does that sort of make sense? Okay, so we don't calculate averages in physics the way we do for basically everything else. Okay. So what I want to do then is write down my givens, so I know that in part 1, the displacement now was 100 kilometers north. And the time was 1.2 hours. In part 2, the displacement was 62 kilometers south. And the time was 0.9 hours. Okay, everyone with me so far? This is the part that's a little different. When I write this formula, V equals displacement over time, this is what this formula actually means. The average velocity is the total displacement divided by the total time. Okay? So my total displacement will be my change in position. I went 100 kilometers north, and then I went 68 kilometers south. What's my change in position?
38 kilometers.
38 kilometers north, right. Okay, so I would calculate that by going basically 100 minus 62, or plus negative 62, whichever makes more sense to you. Okay? Time is scalar, so I don't subtract the time. If I subtracted the times, okay, that means I'd be going back in time. I'm going back in terms of direction, but I'm not going back in time. It's a big mistake if you make it. Okay, so we got 1.2 plus 0.9. And that's why sometimes people think this makes more sense. That way I'm adding both, right? I'm recognizing that south is really negative north. Totally up to you which way you do it. Okay? All right, so what I end up with then is 38 kilometers north divided by 2.1 hours, which will give me 18.1 kilometers per hour north. How important is it to put the north on your answer? Really important. There's two things that cost people marks in physics all the time. missing units, or where appropriate, missing direction. Okay? If it's a vector quantity, it better have a direction. Okay? Because otherwise, it's a speed, and those are not the same thing. Okay. That one make sense? Okay. That's a pretty standard grade 10 science V equals D over T type question. Okay, to have one that's got two parts, okay, where I have to calculate the velocity. Now, this question could also have a part B, where it would say, what's the average speed over the whole trip? There's a lot that's the same for that calculation. What's the only thing that's different in calculating speed? Exactly. I don't care about direction when I calculate speed. So instead of going 100 plus negative 62, I go 100 plus 62. Because it's the distance divided by the time. So if they want me to calculate the speed, it's 162 divided by 2.1, okay? And I get a bigger number because it didn't backtrack. Okay? Velocity is always going to be smaller than speed in a backtracking situation, because your displacement is going to get smaller. Your distance always gets bigger. There's nothing that can make distance get smaller. Okay? Displacement, easy to make it get smaller. All you have to do is retrace your steps. All right? Okay. So tomorrow, we're going to work some more on this V equals D over T stuff. Okay? And yeah, keep plugging away with physics here.